Determine the area of each rectangle. For the rectangles, we multiply length times width, or you might be switching over to the language like base times height. So I have a base of 2.5 down here on problem 4, and a height of 4/5. So I can put an invisible 1 down there. 2.5 times 4 is 10, and 1 times 5 is 5. 10 divided by 5 is 2, so this has an area of 2 inches squared. In your workbook in problem 1, it says the diagram on the right models the front of the iron bridge in Slovenia. That is shown next to it. Explain how you can estimate the area of the figure on the right and identify which lengths you need to know. So if we're trying to identify the area, we could break this up into several different shapes. If we thought of it as one large rectangle, we could then cut it up into pieces that we don't need and subtract that from the rectangle. So for example, we could cut here to create a triangle that we didn't need and remove that. So remove this triangle. We could also cut across this section and create a semicircle that we could remove, as well as a rectangle that we could remove. So now we need to write up kind of a summary of how we plan to estimate the area and what dimensions we would need. So we would create a rectangle outside the shape. Then decompose it, meaning break it apart, and subtract the area not used in the figure. So some dimensions that we would need the height here. We would need the distance across either the like pillar pieces here. So some of these measurements. We would also need the diameter or the radius of that section. We would want the height of the straightaway. And we would also want to know how tall it is on this side. The image of a window from a castle of Tura in Hungary is modeled by the drawing. Find the approximate area of the figure by using either decomposition or composition, meaning putting it back together, and by using 3.14 for pi. Round your calculations to the nearest hundredth. So we're going to use composition, since we can just use two different pieces and combine them. And we use a rectangle, and a semicircle, because we have the formula for both. All right, so for the rectangle, our rectangle piece, I'm going to put a little square there or a rectangle there so we know that that's what we're talking about or referring to. The area is the base times the height. So we're multiplying 4.2 and 8.4 together, which is 35.28. And then for the area of the semicircle piece, the distance across is 4.2. So the radius is half that distance. The radius is 2.1. And again, this is half of a circle, so it's half the radius squared times 3.14. So we're going to square 2.1. Then we're going to divide that by 2 since it's half of a circle and multiply by 3.14, which comes out to 6.9237. Now we're going to find the total by adding these two together and then round our answer to the nearest hundredths. So when we add 35.28 and 6.9237, we get 42.2037. For rounding it to the hundredths place, we're looking at 2 decimal spots. The 3 is not 5 or more, so it's going to stay 42.20, and this is measured in feet squared. I think we should have said that we decomposed it into a rectangle and a semicircle, because here they're using the language that they composed a square around the outside, so they're making it larger. Anyway, find the area of the shaded triangle. So first we're going to find the area of the whole square, and then we're going to remove the triangles that we do not want. So the whole square, 12 plus 18, that's a side length of 30. Here I have 8 and 22, which is also a side length of 30. Oops. And I'm going to remove this first triangle. That is 1/2 the base times the height. So 12 times 8 is 96. Half of 96 is 48. And we're going to use this red triangle. This base is 18 and this whole height is 30. $18 times 30 is 540. Then split that in half, which is 270. And then for this triangle down here, it has a base of 30 and a height of 22. $30 times 22 is 660. Split that in half is 330. So to find the shaded section, we're going to subtract. And that gives us an area of 252. It doesn't have units on here, so we're going to just call it units squared. It says, why did the student use composition to find the area of the shaded triangle? We were not given any side lengths of the shaded triangle. We also do not have a right angle in that triangle, to determine a height. Notice we use these right angles in the corners because we know the base and the height form right angles with one another. Consider the figure. Find the area of the figure by using decomposition. So we're breaking it into pieces we know. So I'm going to cut it this way, and then I'm going to cut it this way to create a triangle. I'm also going to cut it here to create another piece of a rectangle. So this bottom rectangle is a 2 by 11, which is 22. This whole distance is 11, but 3 of it was cut off, which means the piece that's left is 11 minus 3, which is 8. So this rectangle is 3 by 8, and 3 times 8 is 24. This piece was 2 tall, this piece was 3 tall, and the whole distance of this side is 9. So 9 minus the 3 that we took out for this section, and the 2 that we took out for this section leaves us with 4 for this top piece. So I have a 6 by 4, which is also 24. This whole distance is 11, but 6 of it was cut off for this rectangle piece. So 11 minus 6 leaves us with a side length of 5 for the bottom. And this triangle has a height of 4. Remember, for triangles, it's half of the base times height. So we're going to do base 5 times height 4. 5 times 4 is 20. And then since it's a triangle, we cut it in half, leaving us with 10. And we need to add all those pieces up together in order to get the total area. Which gives us 80 units squared. Now we're going to find it using composition. So we're drawing a big rectangle on the outside of our shape. Oops. So the whole rectangle is an 11 by 9. 11 times 9 is 99. Then we're going to remove pieces that we don't want, which is this square, which has an area of 3 times 3, which is 9. And we're going to remove this triangle here. So here was a 2 and a 3. The whole height is 9. So the piece that's left here to make it 9, 2 plus 3 is 5, and 5 plus 4 would make 9. This piece I have 6 already taken up, and I need it to add up to 11. 6 plus 5 makes 11. 4 times 5 is 20, but it's a triangle, so half of 20 is 10. 99 minus 9 is 90. 90 minus 10 is 80. So a different approach but we still ended up with the same area. It says, which strategy do you prefer to use to find the area of this figure and why? This is a personal question. I preferred the composition method using the outer rectangle because there were fewer pieces to calculate. In some cases, it's going to be easier to decompose it, but in this case, I only had to find 3 pieces for composition, but when I decomposed it, I had to find 1, 2, 3, 4 pieces. And with the composition, I found the outer rectangle and I removed 2 parts. So I had to do 3 pieces instead of 4. Find the area of the figure by using any strategy. I'm going to use composition because it will take me fewer steps. If I draw a rectangle around the outside edge here, I need to find the rectangle and this triangle. Whereas if I used decomposition, I would need to find 2 triangles and a rectangle. So the outer rectangle is 1, 2, 3, 4, 5, 6, 7, 8, 9 tall, and it has a base of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 9 times 13 gives me that outer rectangle piece, which has an area of 117. Then for this triangle, it has a base of 13, but a height of 4. Thirteen times 4 is 52. Split that in half, and that's 26. For this method, I am removing this triangle, so I'm using subtraction. 117 minus 26 is 91 units squared. This shape is considered a regular octagon. Octagon, that prefix oct means 8. 1, 2, 3, 4, 5, 6, 7, 8 sides. And a regular octagon means that all the sides are the same length and the angles inside are all the same as well. It says, decompose the regular octagon into familiar pieces. I'm going to split it up into triangles. So connecting here, I can create triangles. And all of these triangles are going to be identical because it is a regular octagon. Describe the shapes formed by decomposing the octagon. There are 8 triangles. that are the same size. The reason I went with these triangles is because then I can find the area of one triangle and just do 8 of them, rather than trying to find the area of different size triangles. So it says, the given stop sign is a regular octagon. Use the measurement shown to find the area of the stop sign. So here, again, for the area of a triangle, we do the half of the base times the height. So 12.4 times 15 is 186, and half of that is 93. So this one is 93. Remember, we have 2, 3, 4, 5, 6, 7, 8 of those. 93 times 8 will give us the full area, which is 744 inches squared. That's all for lesson 16. Check back for later lessons coming soon.